Welcome to Unit 3, Lesson 1, Part 1, Angles and Their Measurements. So in this unit, we're going to be working with something called the unit circle. We'll get there in the next lesson. But the first thing we need to talk about is radian measurement. So it's a comparison measurement that we can use to equate to degrees in a circle. And we use pi in this section of the unit and throughout. So 1 radian is the measure of the central angle subtended in a circle by an arc equal in length to the radius of the circle. So there's an example of that here. Now, we know that 360 degrees is equal to 2 pi, or 1 full rotation around the circle from the origin, or standard position. We also know that pi is equal to 3.14159, often to infinity, and 2 pi is approximately equal to 6.28. So based on the diagram on the right, if you haven't read angles in a long time, just remember that the middle letter is the vertex of the angle. So we would trace it like this: A, O, B. The angle exists here, okay? So 1 full rotation from standard position all the way around, in this circumstance, not necessarily always in standard position, but 1 full rotation around the circle is 360 degrees. That's equal to 2 radians. 1 half rotation, so from here and across to the other x-axis, the negative x-axis, is pi radians. A quarter rotation is 90 degrees, or pi over 2. And 1/8 of a rotation is 45 degrees, or pi over 4 radians. Now, just a little note, you may leave off the radians unit and just write, for example, pi over 2. That's an acceptable and exact answer. So when you get questions throughout this unit that say give an exact answer, you don't necessarily need to convert it to a decimal or anything like that. Pi over whatever you're given is a reasonable answer. So just to start, we're going to look at estimating conversions. So we know that pi is equal to 3.14, etc. So 180 degrees is approximately equal to 3 rads. So if we go through these example questions here, 180 degrees is 3.14 rads, and we can just say that 180 degrees is approximately equal to 3 rads. Apologies, my pen went bad here. Approximately equal to. So your approximately equal to is just a wavy sign on top and an equal sign on the bottom. So 90 degrees, if we're saying that 180 degrees is approximately 3 rads, then 90 degrees will be approximately 1.5 rads. I'm going to leave 45 degrees for you to figure out as one of your practice questions. Now we can also go the other way. So if we have 1 rad, that's approximately equal to 60 degrees, because 3 rads is approximately equal to 180. So just divide that by 3, we get 60. Now, you can get questions like this, 4.5 rads, and I figured it out for you. It's 270 degrees. If you're like, where the heck did that answer come from? Think of it this way. If we know that 60 degrees is 1 rad, then we have 4 of them, so times it by 4. That gives us 240 degrees. And then we add on that extra half a rad, which would be equal to 30 degrees, to give us our answer of 270. So you can go ahead and do these 2 questions as practice questions as well. Now, we can also have an exact conversion. So we have pi is equal to 180 degrees. So the direction says draw an angle in standard position, convert degrees to radians and radians to degrees, give the measurements in exact form, and round it to the nearest thousandth, or 3 decimal places. Just remember, if you have something like that, this is our ones column, our tenths column, hundredths, and thousandths. Okay, just as a reminder. Now, below this, I have 4 examples for you. So our angles are starting in standard position with the initial arm on the x-axis and the terminal arm will end up somewhere in the 4 quadrants. So in this first example, 30 degrees, we have our terminal arm here. To convert it to radians, what we're going to do is multiply the degrees by pi over 180. So when we do that, we have 30 over 180, or 3 over 18, which is equal to 1 over 6. You don't have to do a lot of work here except for reducing your fraction. So at the end of it, you're going to get pi over 6, or 3.14 divided by 6, which is equal to approximately 0.524 rads. Now, in example B, we have a negative angle, and you maybe have not seen that a lot so far. But when we have a negative angle, it just means that we're going in the opposite direction from the x-axis. So instead of going counterclockwise around, we're going to go clockwise around the Cartesian plane. So here we have negative 120 times pi over 180. Again, look here, we have 12 over 18, which is equal to 2 over 3. Don't forget your negative sign. So here we have negative 2 pi over 3. This tells you the direction to move. C, here's another example, 5 pi over 4. If you're trying to convert to degrees, notice that now the 180 and pi have switched because we're wanting to cancel these out, right? This means divide this divided by that, even though we're multiplying. It's common units. So the pi, excuse me, the pi goes away, and then you just multiply out to get your 225. In example D, we're given radians. You can tell because there's no degree symbol. And of course, if it was only 2 degrees, it would be a very skinny angle. So we have 2.57 radians. And the same thing here, we're going to multiply by 180 and divide by pi. Now within this unit, we also have something called coterminal angles. And I want you to think about what the word terminal means. It means like the end, right? And coterminal angles end at the same place. So basically all we're looking at is what are all the possible ways we could measure this 40-degree angle to give us all the coterminal angles. They may be measured in degrees or radians. So for example, pi over 4 and 9 pi over 4 are both coterminal, as are 40 degrees and negative 320 degrees. So here you're going to have a difference of 8 pi, and here you're going to have a difference of plus or minus 8 pi, and here you're going to have a difference of plus or minus 360 degrees. It's really simple. Don't complicate it. And then just watch the direction that you're going. So if we have 40 degrees here, our coterminal angle, negative 320, starts here at the terminal arm and goes all the way clockwise around and hits that angle again. Gives us negative 320 degrees. Notice that these two numbers together add to 360, or our full circle. A little additional note on the coterminal angles. Here we have plus or minus 8 pi to give us the coterminal angles, but notice that we have a denominator of 4 all the way around the origin is 360 degrees, which would be equal to 2 pi. So if our denominator is 4 on our fraction, then of course we're going to have 8 over 4 pi added on, which is equivalent to 2 pi. In this example, we're given two different angles, 40 degrees and 430 degrees. Maybe we'll just work down one side first and then talk about the other side. Now, I do need you to make a correction to your graph here. I have the quadrant 1 going in the wrong direction. For the 400 degrees, it needs to be going this way because it's positive. So just change it up on your graph or draw a new one to reflect that change. So we know that 40 and 400 degrees are coterminal angles. Notice that 40 plus 360 gives you 400. And then it basically just continues off into infinity from there, both in the positive and negative direction. So 400 plus another 360 is 760 degrees. And then a tiny example here, 40 degrees and negative 320. Those are also coterminal. And once you have that negative 320, you can subtract the 360 away to give you negative 680. So if you look further down your page, you have a bunch of different examples of angles that are all equal to each other. It just depends how many times you've gone full circle around that axis. Just think of it like you're a pro snowboarder and you're doing a bunch of spins. Every time you do a full rotation around, you're doing 360 degrees. And the angle that you land at is always the same. It just matters how many times you've spun. On the right hand side, we're doing the exact same thing, except we're going in the negative direction with a negative 430. So notice that we started here and went all the way around. That's 360. And then the remainder to make up the 430. The same thing as the first example, you're just adding and subtracting 360 degrees to give you all of these coterminal angles, negative 790, negative 430, etc. Those are all equivalent to each other and called coterminal. One final example given is done in radians instead. So we have 5 pi over 3 radians. That's an angle that looks something like this. It's in quadrant 4 and it's in degrees equal to 300 degrees. So I want you to remember that 2 pi, since we have a 3 on the bottom here, we want to use similar denominators so that our fractions are easily added together. Remember, when you're adding or subtracting fractions, you do not do anything with the denominator if they're like. You just leave it alone and add across the top. It's okay to have an improper fraction here that tells us how many times to go around the axis to get to our endpoint. So 6 pi over 3 radians, which is of course equal to 2 pi. 6 over 3 is 2. So every time we're adding 2 pi or 360 degrees. Therefore, the exact same thing as we were doing above, except we're adding 2 pi instead. And the coterminal angles will be 5 pi over 3, 11 pi over 3, 17 pi over 3, negative 11 pi, or sorry, negative 1 pi over 3, negative 7 pi over 3. These are all equal to each other. So there's just a pattern here. It's really simple. We add or subtract 2 pi or 360 degrees to find coterminal angles. And in the next part of this lesson, we're going to create a formula, general formula to help us determine how to do that.